Very namaste. Welcome back to my YouTube channel. My name is Anushka, currently studying in Sri Venkateswara College of Engineering. Today we'll be looking at database system environment in which we'll be looking at different components that affect the database system. Let's look into it. Introduction to database systems. Databases are the backbone of modern digital infrastructure, powering essential applications and services across industries. The introductory section will explore the fundamental concepts and components that underpin robust, scalable database systems. Database systems are something that we see around us. We have Oracle, and we have MongoDB that uses NoSQL, that is sequence query language, whereas Oracle uses a SQL query language, SQL. So we have databases that are basically organized data which are in relation with each other in a logical way. So we'll be looking at the components of databases that affect database and other various parts as well. Components of a database environment. Hardware infrastructure, the physical servers, storage systems, and networking equipment that host and connect the database. So we have a hardware infrastructure, operating system, database management system, and data storage and the components of database. The first component is hardware infrastructure. That includes the physical servers, storage systems, and networking equipment that are required to connect the host and the database. We have the operating system, the software that manages the data, hardware resources and provides a platform for running the database. Different operating systems that are used widely in industries, Linux, as well as we have other operating systems as well, which we see around us. The Windows that I'm using or Mac OS if we have one. Database management system. The specialized software responsible for storing, managing, and retrieving data in a database. As I explained earlier, database is where the data is stored in an organized way in which the data is in relationship with each other in a logical way. So there is a database management system that manages and is responsible for managing and retrieving the data from the database. Data storage, the file system, storage media, and backup solutions used to physically store the database components. Let's look into hardware infrastructure. Robust servers. High performance servers form the backbone of the database system, providing the necessary computing power and storage capacity to handle large volumes of data. So, in the hardware infrastructure, the first component is the robust server. The servers are very important in order to manage your database. A high the performance of the server is, the better the database is, and they form the backbone of the database, providing the necessary computing power and storage capacity. Then we have scalable storage. Reliable and expandable storage solutions such as enterprise grade SSD and HDD arrays ensure that the database can accommodate growing data needs. So scalable storage is essential as well because it should be reliable and expandable. As data is something that keeps on growing, it needs to be the storage should be scalable, that it should be reliable and expandable. Reliable networking. So is the third part. Robust networking infrastructure, including high-speed switches, routers, and load balancers, and enable efficient data transfer and communication within the database environment. We also need reliable networking in order to ensure that the switch is made efficiently. If there is any switch or transferring data, it is made efficient. Operating system consideration. Now, what should we consider? We looked into the four components of database. Now, we are looking into each one in specific. First, we looked into hardware infrastructure. Now we're looking into OS, which we need to consider while choosing an OS. We need to consider these four aspects. Number one is compatibility. Number two is performance. Number three is security. And number four, but most importantly, scalability. Number one, compatibility. The operating system chosen must be compatible with the hardware infrastructure and support the specific database management system. Yes, that's very important that the operating system that you use should be compatible with the hardware infrastructure. Otherwise, it won't be of any use. Next is performance. The operating system should be optimized for database loads, providing efficient memory management, disk input output, and CPU utilization. Performance is also another important aspect of the operating system that should be optimized for database workloads. Security. Now, security is really important concept as when you are trying to manage database, and if that data has really important value for the country or for your city or for any aspect, as it could be important of any, it could be importance of, can hold importance of any, for any aspect. Security is must and should the topmost priority. A robust operating system. Security features are crucial to protect the database from unauthorized access, data breaches, and other cyber threats. Yes, security should be considered at most. Scalability. The operating system should be able to scale to handle increasing database size, user load, and transaction volumes without performance degradation. Database management system. Now, that is a software which manages the database. At the heart of any database environment is the database management system, the software that controls and manages the database. DBMS is responsible for storing, organizing, and providing secure access to the data. Key DBMS capabilities include data definition, data manipulation, query processing, transaction management, and backup and recovery. The DBMS also handles user authentication, access control, concurrency, and other critical database administration tasks. So database environment, the heart of database environment is nothing but your database management system, the software that controls and manages the database. The DBMS is responsible for storing, organizing, and providing secure access to data. So as you store the data, you need to access the data, right? You can just not keep storing it, and you need to store, organize, and retrieve the data. The database management system comes in handy here. It is basically the software that manages your database. The capabilities, the key capabilities of database should be data definition, data manipulation, query processing, transaction management, and backup and recovery. All these the six aspects are very important in order to keep the database working properly. Data storage and file system. Now, this is also a very important aspect. The last aspect or the last component of database environment, database storage. Databases rely on specialized data storage technology to efficiently manage and retrieve large amount of structured data. This includes like indexing, partitioning, and caching to optimize performance. Indexing is you store the data and you give an index number related to it. You can relate to this as your index page where you write the content and related the serial number and page number. That gives you an easier access to attain the data that you have written. Likewise, indexing is nothing but giving it a key value in which you can refer to see what the data is about and where it is stored. Partitioning is basically divide and rule method where you divide the data and make sure that you know where you have kept it. When you have caching, caching is nothing but cache memory is basically the memory that you need to keep on frequently be calling. So there can be certain data that you would want to retrieve again and again. So you can use the method called as caching. File systems. The underlying file system is crucial for storing unstructured data, logs, and other supporting files. Considerations include file system type, permissions, and backup recovery capabilities. We have third, storage hardware. Database environment leverage a variety of storage hardware like this hard disk drives, solid state drives, and network attached storage to meet performance, capability, and cost requirements. We also have storage hardware, which is a very important aspect again, that is to leverage a variety of storage hardware like hard disk. All of these are basically to make sure that the storage is at most done for the database management. Network and connectivity. Robust network infrastructure is essential for database system environments. This includes reliable internet connectivity, secure virtual private networks, VPNs, and high-speed local area networks that are LANs to ensure seamless data transfer and real-time access. Again, network and connectivity is a main issue that a lot of databases face. That's because data can be stored, but in order to retrieve and share it is one of the major tasks faced in IT. That is to load the data from one end and to transfer the data from A to B. So network and connectivity is an important aspect. Redundancy and failure mechanisms such as load balancing and failover clustering help maintain availability and prevent single points of failure. Careful network configuration and monitoring ensure optimal performance and security. Access security and access control. Access management, which ensures that only the user gets the only the authentication. After the authentication of the user, then only the user will get the access. Implement robust user authentication and authorization mechanisms to control access to the database and its sensitivity. Network security. Secure the database network infrastructure with firewalls, VPNs, and other security measures to protect against unauthorized access and cyber. Data encryption. Encrypt sensitive data at rest and in transit to ensure confidentiality and prevent data breach. So you need to encrypt your data, make sure the network is good, and the user should be the only one to access it with authentication. Backup and recovery strategy. Backup planning. Establish a comprehensive backup policy, backup execution, implement automated reliable backup processes, restore testing, regular verify backup integrity and recoverability. So backup and recovery strategies are really important here. Robust backup and recovery strategies are essential for safeguarding critical data in a database environment. This includes proactive planning to define backup policies, implementing reliable backup procedures, and regularly testing the ability to restore data from the backups. A well-designed backup and a recovery plan ensures business continuity and protects against data loss in the event of system failure, human errors, or other disruptive incidents. Till now, we had understood how to store, how the data is stored, how the data is managed, how the storage has been done. But backup and recovery strategies are also an important aspect because you'll be handling a lot of data. Monitoring and performance tuning, real-time monitoring. Continuously track key performance matrix like CPU, memory, disk, input, output, and network utilization to identify bottlenecks and optimize resource allocation. Now that you have understood everything, monitoring and performance tuning is a very important aspect. Proactive optimization. Analyze historical trends to predict future resource demands and proactively tune the system to maintain peak efficiency. Scalable analytics. Leverage big data tools and techniques to collect, process, and visualize massive amounts of performance data from in-depth analysis. Automated adjustment. Implement self-healing mechanisms that can dynamically adjust system parameters based on real-time conditions to ensure consistent performance. So that was about database system environment. I hope you all have understood this. If you have understood this, please make sure to give this video a like. I'll see you in the next one. Thank you.